So we get to proper confidence intervals. Now we need to construct these lower bounds and these upper bounds. We call them limits, bound limits. Now the sample statistic, remember this, whether it is the mean of a group or the difference between two means, is just one of countless many that could have been found. So we really are talking central limit theorem. So what we are going to do is we need to find out how many standard errors away from that sample statistic we have to be to find about 95% of all the values if we choose our confidence level to be 95%. Now remember, the sample statistic would be at the middle, in the mean, and we just have to work out how many standard errors away from the mean we have to be for our specific confidence level. Now remember the z and the t distributions. If we knew the population standard deviation, we could use the z distribution. If not, we are going to be stuck with the t distribution, and this is exactly what we're going to see. Now look at it. If we were to include 95% of all the values under the curve, an area that represents 95% of the area under the curve, you would see what the values are there. They are slightly further out. If we narrow that gap, if we make our limit bounds a little bit smaller, closer to that mean, we drop our confidence. Our confidence level decreases as we make our little gap, our little range smaller and smaller. Now, what is really this true interpretation? If I were to say that the 95% confidence interval was from A to B, what does it really mean? Now, take an example. If I were to do a study on the exact same population parameter, so we're choosing a population parameter, and we are going to take a sample, and for that same parameter, we're going to work out a sample statistic. Now, if I were to repeat this study with different individuals 100 times, and in each of those times, I work out the 95% confidence interval bounds, it would really mean that this population parameter would fall within those two bounds in 95 of those 100 cases. So I do that study 100 times over. Every time I'm going to find slightly different 95% confidence intervals, a lower bound and an upper bound. That true population parameter will fall within those 95 times. It is not true to say that there is a 95% chance that the true population parameter is within the bound set by a single study. It's an all or nothing thing. Either that population parameter is within those limits or they are not. But if I could repeat it 100 times, in 95% of cases, it would actually be correct. The true population parameter would fall in between those. So it's a subtle little difference, but it's the proper understanding, a proper explanation of confidence intervals.